30, 12, 19, 14. So that's going to go 12, 14, 19, 21, 26, 29, and then 30 appears twice. Does that look good? 30 appeared twice. It does. Okay, so what do I need my median. I have 1, 2, 3, 4, 5, 6, 7, 8. So since I have 8 elements in the set, then I have to take the middle 2 and average them. Add them up, divide by 2. So I'll write them out. The median is 23.5. And now I'm not the mode. Sorry, the mode doesn't appear as a bar in the box and whisker. Neither does the mean, but the median does. So what else do I need? I need to know the first quartile and the third quartile. So to do those, when I have an even number, I can go ahead and include this left 21. So I know they're 21 and 26. I can erase those. So 21 will be in the left half, and then 26 will be in the right half. And then I'm going to go ahead and I'm going to average these two to find the median. Add them up, divide by 2. So the median of these two numbers is 16.5. So that becomes the first quartile. And the median here is 29.5. Alright, so what else shows up on a box and whisker? I need the lowest and the highest. So my lowest is 12. My highest is 30. So this isn't really going to be to scale, but sort of have a dot at 12, and then that's going to come out to 16.5, and then my median is, again, this would be sort of to scale, you know, in the best case scenario. And then the third quartile is up here, and that's 29.5, and the high is 30. So the high is really just over that. And I'll write it up here, even though it doesn't look kind of clean. So you should show at least that the distance between your third quartile and your highest value is much less than the distance between your lowest value in your first quartile. The only other thing that we one other thing we sometimes look at is extreme values, which would come out as a star, but none of these are extreme values like a mistake. An outlier is the word for it. It's so many standard deviations over. So we're not calculating any of that. Box and whisker plot for this question, this would be sufficient. So that is 39. Let me go ahead and clear the board. Coming down the last couple weeks of school. For many of you, of course, depending on when you're watching this, 40 is find the range in IQR, or interquartile range, of the data rounded to the nearest tenth. Okay, so my data points are 43, 47, 39. 43, 47, 39, 36, 20, 47, 31, 26, 51. I've short arms. Okay, so let's put these in order. Six, 20, 20. What do we got? 31, 36, 39, 43, so I'll cross it out, 47, two of those, 51. Okay, so how many data points do we have? Is it even or odd? 1, 2, 3, 4, 5, 6, 7, 8, 9, there's 10. So 1, 2, 3, 4. So I have to average the 2 in the middle to get my median, which is what, 37 and a half. Oh boy. Okay, and now what do we want to do? We want to find the median of the lower half of the data set. So again, because I have an even number, because I'm averaging the 2 in the middle, I'm going to go ahead and include the one on the left with the lower half and the one on the right with the upper half. If you had just one median, you would ignore it for the IQR, for the first quartile and the third quartile. So looking at these, 20. Because now I have 1, 2, 3, 4, 5, an odd number, so the median of that lower half will be on there, 20. And here it'll be 47. And then IQR, I guess it did it ask for the median? No, it just asked for the range and the IQR. So we don't need the median to calculate that. I guess I'll leave it off. The IQR is the third quartile minus the first quartile is 47 minus 20 or 27. And what is it? Does it want the range? No. Oh, find the range and the IQR. So the range is the highest number minus the lowest number. So our range is 45. Our IQR is 27. IQR, it's a measure of spread of the data. The range will always be higher than the IQR unless your data set is just like the same number over and over and over again. Okay, so that looks like the end of the sort of data sets. So I'm going to go ahead and erase there because it looks like we're going on to solving systems of equations, and I could probably fit one in there, but it just takes a minute. Let's see what we got. 41, solve the system. Y is equal to, does it say how? Oh, it says using substitution. Y is equal to x plus 6, and then I'll write the second one in blue. Y is equal to negative 2x minus 3. Sorry for the sound effects. Okay, so by substitution it's saying, well, if y is equal to this quantity and y is equal to that quantity, then I can set those two quantities equal to each other. So I'm going to say that x plus 6 is equal to negative 2x minus 3. We'll add my 2x to both sides. I'll get 3x plus 6 is equal to negative 3, subtract 6. 3x is equal to negative 3 minus 6, or negative 9. Divide by 3. X is equal to negative 3, so we just sort of save that. And then what we'll do is put that into either of our original equations to find y. So y is negative 3 plus 6, or 3. So now we're going to check this. We're going to say, okay, does 3 equal negative 3 plus 6? And it does. And does 3 equal negative 2 times negative 3 minus 3? And it does. So you could say that you could either write x equals negative 3, y equals 3, but usually what is the system, what is the solution of the system? Well, these are linear equations, right? They're lines on the xy plane. So if they intersect, that's the point of intersection. So the point of intersection is the solution, negative 3, 3. Right? So if it's two lines, they'll either you'll get, if they intersect, you'll get a point. If they're two parallel lines, so if this is, say this was like negative 2x plus 6 and negative 2x minus 3, so if you had the same slope, parallel lines, they would not, you'd have no solution. Or if it's the same line written twice, right, basically the same line over itself, that would be infinitely many solutions. But we won't get into all that. That's the solution using substitution. So I think I can do 42 down here. 42. I guess it's also, yeah, this is also substitution. 3x plus 2y equals 7. And y is equal to negative 3x plus 11. So this is also set up nicely for substitution. When you have at least one of them, one of your equations isolated for a variable like y, then it makes it easier for substitution. You know, you could rearrange this and do this a number of ways, but you know, we'll do it the way they ask. So what I'll do is I'll substitute negative 3x plus 11 for y here. So I'll get 3x plus 2 times the quantity, negative 3x plus 11 equals 7. And I will go ahead and distribute that too. So I get 3x plus 2 times negative 3x. So that's 2 plus a negative. I'll just go ahead and write minus 6x, and then 2 times 11 plus 22 is equal to 7. 3x minus 6x is negative 3x plus 22 is equal to 7. This is come out nicely. Should. Negative 3x is equal to negative 15. Divide by negative 3. Divide by negative 3. X is equal to 5. Now what? Okay, well, now we have one of them. So now we're going to, we have x equals 5. We're going to substitute that in to either of our original. So this one's isolated for y, so that makes it easier. But I could put 5 in here and then solve for y. I'm going to do it here. So that's y is equal to negative 3 times 5 plus 11, negative 15 plus 11. Right, so our solution is x. The x value is 5. Negative 4. So I'll just sort of check this. Negative 4 times negative 3 is, no, something's not coming out right. Sorry, 5 times negative 3 is negative 15 plus 11 is negative 4. And this is 15 minus 8 is 7. So those check out. So why do I write them with these and with the parentheses instead of something like that? Well, our solution is a coordinate point. So it has an x value and a y value. Okay. What's next? Uh-oh. I lost my... Give me just a second. Okay, data analysis. We have one, elimination. I got a couple here with elimination. 2x minus 2y equals, can we see that? Yeah, is that starting to focus? Doesn't like me. -8. Now I'm losing it. Let's try that again. X plus 2y equals -1. And this is number 43. So for elimination, what I want to look for is that coefficients that are equal or that are opposites of each other. So I have 2 and 1. Here I have -2 and 2. So when they're opposites, like -2 and 2, I will add these. So I'm going to add these vertically. 3x. So these cancel. That's what I want. I want one of my variables to cancel. 2 equations, 2 variables, we should be able to solve it. So I'm adding. So it's -8 plus -1, or -9. Divide by 3, divide by 3. X should be -3. Now I'll put that into either one of my original equations. I'll put it